Okay, I'll take care of it. Thank you. I don't have a microphone, so if I'm not loud enough for people at the back, just let me know. And I'm also a little bit unrehearsed, but I'll do my best because I really like this topic, and I think that it might be helpful for other people. Oh, cool! This actually worked. All right, so we'll try this later on. Okay, so I understand that we have like half React web people, half React native people, and then some guests. Is that right?
Yes.
Something around that. So there's not a lot of knowledge that I can assume, but I assume that most of everyone here has used React before, but maybe hasn't dived into the internals of React. I have made a couple PRs and done a little bit of digging into it, but I can't claim to be an expert myself. But I think that every one of those talks that Wei talked about earlier is me just digging into the philosophy and just making it into a talk as I go along. And so far, this is the most in-depth one. And when we're talking about possible topics, I think this is the one that I'm most excited about right now because it really demystifies the framework if you can build it by yourself in 130 lines of code. And that's the promise that I'm making to you today. So we're going to build concurrent React from scratch. And the other thing is that React actually, in the past 2-3 years, has changed paradigms completely from the stack reconciler to concurrent mode. It was completely invisible to you under the hood because you just kept writing the same components. But now, with the release of concurrent mode and suspense and time slicing, you start to see the effects of it. So it's better. So now it's actually the time to start digging into like what the mental model is and why it's important. Okay, so we're going to talk a little bit about a few different topics: React Fiber, linked list traversal, render versus commit. We're also going to clone a use state hook. That's just one of the hooks. Obviously, there's a lot more other hooks, but once you've done one, you can do a lot more. We're going to talk about what the work loop is, time slicing, and suspense. Just to get a sense, because I don't come here normally. Like, how many people like have actually looked into React Fiber, like seen Andrew Clark's repo and all that? Has anyone looked into React Fiber? Okay, so completely new. Okay, good. Good. This is the best intro in the world right now because it is the most accessible. I'm not like trying to Halian. Like a lot of people like they get too in depth, right? And they are no longer able to explain to common people like us what React Fiber is. And I think if you want to do it, you need more accessible steps to get to that point. So I just want to give some shout outs. I did not figure this out on my own. Most of this work comes from Rodrigo Pombo. That's the guy on the top right. He wrote this project, Build Your Own React. He's been working on this for 3 years. And it's a simple step-by-step clone. But it's a very, very faithful clone. And it takes quite a few hours to understand it. So in order to dial it down, I have to incorporate some other ideas. In the middle, that's Andrew Clark from the React core team. And there's Lynn Clark at the bottom, who gave the first big talk about React Fiber. And I recommend all of their work to understand if you want to go deeper. We'll start off with what a JSX element is. Everyone should know what a JSX element is. It's a plain old JavaScript object. It's just an object. It has 2 primary keys. There's actually a couple more, but those are the 2 primary ones, type and props. And it looks like this, right? Like this is very, very not alien to everyone here. Like you have an object, you have a type, you have a props, and inside of them you have a text child called hello world. Obviously, we don't want to write all day long, so we have a helper function called react.createElement, right? And obviously, it's a very short step from there to JSX, which is what we know and love. Okay, so that's a JSX element. How do we flesh that out into a fiber? It really is a JSX element plus a whole bunch of stuff, right? So stuff in red is stuff in red are unique properties like a link to a virtual DOM element, hooks and effects for like the kind of work that you want to do. We'll talk about this. We won't talk about this today, but you can ask me about it afterwards. The white stuff is linked list. So it's every fiber represents a node in your app, and it links to another fiber, and it links to another fiber, and it's bidirectionally links. It's more than bidirectional. It links to its own parent. It links to its immediate first child, and it links to its own siblings. So that data structure contains all the links you can possibly want to go up and down your app stack. I hope that's quite obvious after I explain it. Okay, so let's write it. This is the part I should have. Okay. Okay, I already. Let's see. Okay, and sorry, let me just do some prep for this because it's not super prepared. Okay, so right now what I want, and I'm trying to resolve to do it bigger so it's easier to see on screen. Last time I did this, I did it way too small and only the front row could see, so that was really bad. So what I have here is a project. It only has index.html. It has Babel installed. Those are the only dependencies I have, just Babel. And it's got an index.html with a root, and pointing to the source of that root over here. Okay, I should not navigate randomly. Sorry. I don't know why I'm nervous. I've done this before. Okay, so, and the only thing I have here is styles.css. Okay, that's just producing this very nice animated background. Okay, so the first thing we're going to do is we're going to set up the globals that we're all going to draw upon for this project. So that's the basic setup. I have a utils file. Let me show the utils file quickly. Where's the utils file? It's not toggling out. Give me 1 second. I think I may need to fork this. Just give me 1 second. It's not going too well. Fork sandbox. Okay, fork your own sandbox. That makes sense. All right. Okay, so we have a utils folder, and this folder only has about 130 lines of helper code, right? And it has simple things like reconcile children, create elements, create text element, and create element you might expect is just the helper function that creates types and props, exactly like you expect. Create text element, create DOM, commit deletion, update DOM. So just 120 lines. I'm not extracting away much, but I'm just importing them into this app. And then I'm declaring a bunch of variables that we're going to use. So next unit of work, the current root fiber, the work in progress root, and we'll talk about toggling between the current root and the work in progress root and how that works. The deletions, work in progress fiber, and hook index. All of these are we're going to gloss over a little bit, and then we'll have a variable here called React, and that will be an object that has all the properties that we expect out of the normal React methods. Okay, why am I so nervous? So that's the basic setup, and now we'll write our first fiber, right? So I've written a simple fiber over here, and what that is. Oh man. Okay. I have. Why do I have a random host component thing over here? Okay. Hang on. I think I need to comment this out. I think I pasted the wrong thing over here. Work in progress. Okay, so this is the structure of a basic fiber, but we don't need any of this. So I'm just going to comment it out. All right. So like I said, a fiber is basically that same JSX element, but with all the other relevant tag stuff. We don't really need that. So you know what? I'm just gonna explain that the fiber is not something that we need over here, and so I'm going to set up a work in progress root fiber. So this has a link to two things. So a document.getElementById. by ID. So this is a real DOM node, and I'm going to stick it on the DOM property of the work in progress root fiber, and then I'm going to have a JSX element, and then I'm going to stick that as the first child of that. Of the element, and then these are just like reminders to self that these are all links to other fibers that you could have in future. That is in the data structure of a fiber, but you don't really need it right now. So bare minimum fiber looks exactly like a JSX element. Makes sense. Okay, let's get something to show up on screen. So over here, I'm using JSX to display hello world. Let's actually try and render it. So I have a function for a simple render. And the simple render function basically does this. Takes an element and a container, and based on whatever element type, it creates those DOM nodes using the DOM APIs. It goes through every single property and then attaches it to that DOM as an attribute or a prop, and then it renders it out and appends child to the container, right? This is all standard vanilla JavaScript that you would write yourself if you were making an app. And so part of the framework is to extract this away from you, right? Now I have a render function, and I can render whatever I like, from an H1 to like a div with maybe like a UL in there. It'll become more relevant why I'm doing this later on. Shopee. Is it 1P or 2P?
It's 1P.
Oops. I'm learning, okay? I'm learning. I'm sure Ronaldo doesn't know if it's 1P or 2P. Anyway, so hopefully everything is super clear. I want to go slow in this beginning part because I lost people last time, right? So I really want we have a work in progress root fiber. So we have this JSX element, right? We stick it in a work in progress root fiber, which contains this as a prop and this container. Then we pass it into a render function that says we render the element and the container itself, and that's all showing up on screen there. Very clear, right? Okay, so and so that's the base part that we have to start talking about. What is rendering in React? And I'm just mostly gonna stay in this mode so that I can quickly toggle back and forth. So a very naive way of rendering. Right now, what we're doing is we're starting at the top of this div, and then we're saying let's render everything all at one shot, right? That's fine if the app is small. And let's see what happens as we go along. So this is render and commit. Okay, not an official term, but I think it's a very easy. It's much easier to explain in contrast to what I'm about to explain afterwards. So render and commit. We start at the root and we do work and then we save it to a DOM. So those are the emojis that I chose, right? Work and save. Then we go to the div. We do work. We have that rendering function worked out, and we save it to the DOM immediately. Work, save. Work, save. And at this point, if I come along as a user, there's a chance I might see what this is. I mean, there's different terms for this. You can call it inconsistent state, or you can call it tearing if you borrow the game development analogy. But basically, half the app is updated and half the app is not, right? So that's not a good experience for your users. Anyway, let's keep going. Do work and save. Do work and save. And then once you're done, and that's commit and render, right? Every single step you commit and render along the way. So obviously you can do a little bit better, and the way that React has done this for a long time, it's not even anything to do with concurrent React. It's a render then commit sort of mental model. So the way you want to think about it is that we have that work function and it's attached to the work in progress root fiber. By the way, in my code I'm going to call this perform unit of work, but that don't really worry about that. And we're going to follow this traversal algorithm, right? So you go from the div down to the first child. We do the work. We're not saving. We're not committing to the DOM. Then we keep doing the work. We're not saving. We're not committing to the DOM. Do the work. And this algorithm is very much prescribed. This is the linked list traversal algorithm in React. I have a link for you to learn more about it later. So if there's a first child, you go to the first child. If there's no first child, then you go to a sibling. If there's no, and then from the sibling, if there's a first child, go to first child. If there's a sibling, you go to the sibling. And then if no child, no sibling, you recurse all the way back up. Does that make sense? So that's a very sort of deterministic way of traversing your entire app. And the whole idea is that we'll do all the work in one shot, right? But not commit it. And only once we've done all the rendering work, which is running your code, like your like set state, whatever. Once we've done that code, then we transfer it over to the current root and commit it to the DOM. Yeah. So in that case, you have a very clean cut over from like old state to new state and no tearing in between. For React, that is very, very essential. And in fact, there's a core goal of concurrent React and time slicing in particular. Okay, so if you want to learn more about traversal, Sebastian Markberger, like he actually wrote about this 3 years ago, just like in sketching out what the fiber architecture looks like. So if you go to the React repo and look for issue 7942, you can find it there. Okay, so that's linked list traversal. We don't even need to really do any. Okay, so we have a simple render, but this rendering does the rendering work, right? And then it also commits at the end. This append child is the committing, and it does it per node. So we need to refactor this a bit to actually do a more realistic render. So from this simple render, I'm going to kick out the render, and then I'm going to do a more complex render. And I call this the fiber render in my work. It's a little bit more work, but if I reduce it to this, it makes a little bit more sense. Okay, so we're going to perform unit of work. So this is the core of it. We're going to start off with an object called next unit of work. We're going to, at the beginning, we'll assign it at the root. Like we start at the root, right? And then while there is a next unit of work, we'll just infinite loop until it's done. Okay, so next unit of work. Then we have this function called perform unit of work. It performs the rendering function on the next unit of work, which is currently the work in progress root. But it returns the next node, right? And then you assign it, and then you perform it again on itself, and it just loops all the way through until you loop through the entire app, like we talked about. Then you commit the work. So that's encapsulated in these two functions over here, which I'm purposefully sort of including for you. But just to show a little bit, it does the reconciled children work that I've imported from a utility library. That's the rough idea. I really want to stay high level, right? Because this is a lot to get through in a single talk. And then we also do the commit work thing. And remember, we only do a commit work at the end. Commit work basically just does the append child, update DOM, or delete child functionality. So within this 78-line piece, we already have something more or less working. I think I should comment this out. Yeah. So I always want to show you, like, at what point do we have working code? At what point do we have partially broken code? So like at every step of this point is a workable framework, but it adds more and more features. What's the feature that we've added? We've added nothing actually. We just evolved our rendering function to split it up in that order that we talked about earlier. Render then commit. Whew. Okay, so an app that just does this, not very helpful. We need some interactivity. So then we'll introduce this concept of a work loop. And when I was first told about this, I was very shocked because you're supposed to avoid infinite loops in your code. But surprise, there's an infinite loop in React, and that's the work loop. And it's similar to basically any operating system, any game engine, that there is an infinite loop somewhere in there that's driving everything. That's what really the core of the framework, which is like you register all these callbacks, and then the game loop just decides when to call your callbacks, right? So that's the rough principle for why do a work loop. And the reason why we need one is because this work is only done once. You start at the work in progress root, do all this, commit to the DOM, and then that's it. You need to loop it again, right? So I'm going to delete this and show you the work loop code. And so this is the work loop code over here. I hope this is right. Let me see. Work loop. I think I need to call it. Did I put it in myself? Okay, so request idle callback work loop. So it's not running right now. I don't really know why, but I think I did remove the render. No, I mean I haven't implemented. I removed the simple render function, but I haven't introduced it just yet. Okay, don't worry about it because I'll probably reformat this in a bit. Wait. Okay, sorry, I can't. Yeah, render is not defined. Why is render? Where do I use render? Yeah, that's fine. Yeah, I can clear console. Let me just refresh this. Live coding fail. Okay, so this. Okay, if anyone spots anything, you get a gold star.
The work you said concurrent is assigned value whenever used. So is there somewhere you should use?
I should probably use the current root. That's right. No, actually no. It's unused. Okay, don't worry about it. I'm sure I'll figure it out later on. But the main thing I wanted to talk to you about is okay. Sorry, that really threw me for a loop because that's supposed to be working code. The main thing I want to talk to you about is this work loop, right? What have we done? We took that same loop of like do work and then iterate through the entire app, and then commit the work. We took that same loop and then we stuck it inside this function, and then we did this recursive thing. So we call it one time, and then at the end of the function call, we call ourselves again a second time. So that's the infinite loop there. We're using this unfamiliar API called recurse idle callback. Most people will not have used it. Just think of it as set timeout with a slightly different API. So over here, the internet is very slow. Okay, fine. Oh. This is called state tearing. It should not render. Yeah, I should be on Shopee's internet. Shopee A. Yeah. Okay. I don't know. Anyway, doesn't matter. Just think of it as a set timeout, and the main thing that it gives you is a deadline. So, for example, if you're trying to render 60 frames per second, every second is 1,000 milliseconds. 1,000 divided by 60 is 16.6 milliseconds. So, in that 16.6 window, 60.6 millisecond window, you have the ability to do as much work as you can. And the goal is to use that to yield back to the browser so that they can take in other inputs like clicks and typing and all that. So your app feels more responsive. Unfortunately, right now, we have this infinite loop. We have this like non-stop loop, right? It just says while, and then blam, just goes through the entire app. So we need to break it out a little bit. So let's implement time slicing. So we'll say, we'll have a simple little Boolean called should yield. And we'll say false. And then we'll take this deadline API, and we'll just say like deadline.time remaining less than 1. So deadline.time remaining is the DOM API's way of telling you like how much time do you have left before I need it back so that I can do my browser stuff. So we'll just say if it's less than 1, we'll say we should yield. If it's more than 1, you can keep doing your work. So let's implement this should yield. Basically, while next work is truthy and should yield is false. Something like that. And that's a very simple implementation of time slicing. There's a question over there.
No, I think usually the next unit of work will be assigned to work in progress. That's what it's talking about.
Yeah, you think I did that? There's a chance. Yay! Well done, gold star. Gold star. Basically, what happened was I've given this talk before, and I had the presentation. It went fine the last time, but then my hard drive crashed, so I had to recreate all the copy pasting stuff today. So yeah, sorry, but good catch. Yeah, and in fact, we'll take this fact later on to do the hook stuff, because the whole idea is that you have this infinite loop, and whenever you want to do work, just pop it onto the thing called next unit of work, and the rendering engine will take care of it for you, right? Because we have this infinite loop that's constantly checking if next unit of work is truthy, right? Okay, so that's good. So now we've implemented time slicing, and this is not theoretical. Like this is a real thing in your app right now. If you switch to concurrent mode, there's a strong possibility that you'll see some more sort of interactivity because of the time slicing. So so this is an image from Andrew Clark where he was showing how like you start, in synchronous mode, you start doing this rendering work, and you do it all the way through your entire app, and then you commit to the DOM. That's how React used to work in the stack reconciler mode. In the fiber reconciler, we're breaking it out every however long you want. The reason you use request idle callback is because based on your device, on your mobile phone or something, you might want something less than 60 frames per second. But the whole idea is that whatever the window is, you're doing your work within the window. You yield back to the browser, let the browser do its thing, and then you continue doing your work. And only after you're done doing the whole thing, then you commit. Same principle in both cases, but here you're chopping out the work, right? And it makes your app a lot more responsive. This isn't just theoretical. You can actually implement, toggle your app back and forth. An expensive app, take something that's kind of chunky and laggy. If the rendering is super expensive, you can actually see it in your DevTools if you turn on concurrent mode, and you can see it chopping up inside of your flame profiler, whatever you call it. Is it flame profiling? Yeah. I don't. Honestly, I just don't have this scale of app to really test it on. But yeah, I mean, it's absolutely there if you need it. Okay, so that's time slicing. Now let's actually talk about a hook, because some interactivity is needed. And the way we're going to implement the hook is just another function. So I'm just going to paste in this function. This one is most related to the one to the talk I did previously, the previous time I came here. And basically, it's a function that replicates the hook API, right? So you have a set state, and then you have a hook.state over here. And then you return that as an object. So as a consumer, you just call your useState and get this out. The primary thing, what is this linting error? Okay. Another bonus point. Anyone knows what this is? Optional chaining. Yeah. So I'm using this just because it's in the standard now, so we can all use it and with abandon. It just makes your code a lot nicer. Like I would have to do a lot of and in there. Okay, so the main thing we should take note of is inside of this set state thing, which is exactly right. Whoever that was who helped me out just now. In order to set state, we're not calling like some React.render again. React render is running already. There's an infinite loop. Instead, we're just chucking something onto the work in progress route and then put it into the next unit of work and let React pick it up whenever it's ready. And that's how you schedule a set state. You're not, and this is the primary thing why React is not reactive. React is not reacting to your user input. You're only scheduling a state update, right? And that's why everything is async there. So a lot of beginners will trip up on that if they're not careful. Okay, so so let's actually use useState in our app. I think I have a basic little app prepared. Okay, basic app here, and then I'm going to delete the old app. Again, I screwed something up. Let's see what I screwed up. Okay, and then I need to expose it to on the React object over here. Okay, yay! Nice. Okay, thank you. I always do this. So every one of my talks, I'm always creating a framework from scratch, and then I always end at like, hey, let's do a clicker, and then everyone claps, and then I go home. But let's do something more ambitious, right? Like so now we've proven that this looks exactly like a normal React app that you write on a day-to-day basis, and we've cloned every single thing from the bottom up. And so far, we've only taken 120 lines of code. That's good, not good enough. Let's keep going. So, React is also changing in terms of its render API, right? So we actually haven't even written the render function. I'm actually a little bit apologetic about that. Yeah, so we have this work in progress root function over here. It's not very nice. We should actually have something nicer. The way that we really want to write our apps is using this render, like React DOM.render or something, right? Render element container, whatever. So let's see. We have a render function here. And so we're just taking this work in progress root thing and we're just sticking it inside of a function, and then we'll call render element container. Let's actually put it next to each other like that. So same deal. It's just that now we have a function to do this, so we don't see the ugly part. And again, this is the kind of code that we write, right? React DOM.render element in a container. Yeah. Okay. But in concurrent React, we're actually changing that API a little bit to a create root API because you can have multiple roots. So the API is pretty. It's just like a small difference. So I'm just going to say create root. Change this to create root. It takes the container and it returns an object with a render method, which has that element in there. And then I'm going to cut this, paste here, and now I can say create root dot container and an element again. I think I think that should work. Did I screw that up again?
Not render.
Huh? Oh, yeah, good choice. This is so much worse than last time. Okay, okay, that works. Thank you very much. In fact, I'm going to expose it on the React object as well. Okay, so yeah, so that's the create root API. It's slightly different just because they wanted you to have more options when you're creating routes, but just don't worry about that. Just when you move to concurrent mode, this is the kind of thing that you need to take note of. Very, very small changes. Okay, so in the last bit, we're going to talk a little bit about suspense because at this point we have a fully functioning React clone, and we'll just talk a little bit about how you can take this mental model and tweak it to understand new things that are coming up. Okay, so first of all, I'm going to extract everything that we've done so far into a standalone file because this is getting a bit long. We're going to call it react.js because why not? Okay, I'm going to cut, paste, take this as well, and paste over here and export here. Hopefully that I need to take this as well. Okay, that looks like it. I got everything. And then I can import React from react.js, whatever. Let's see it work. Where did my thing go? Wait. Does anyone know Code Sandbox well enough to view? Wait, where is it? Where'd it go? Toggle preview. Where did it go? Do I just refresh? Okay, I'm gonna save it and I'm gonna refresh it. When in doubt, just restart. Of course, right? Okay, but now it's very, very convincing. Now it's very scary how close it looks. Look at this. It's pretty nuts. Okay, so let's talk about suspense. So I'm going to poll the audience again. Who here has an inkling of what suspense is? Has tried out suspense? Nobody? Okay, about 5 people. Okay, so suspense is a way. So how do you fetch state in a hooks world? How do you fetch data in a hooks world, right? There's no component did mount or something, or you can do event handlers for sure, but typically you have to stick it inside of a react.use effect. And then maybe you need a ref, or you need to memorize, or you do some other BS to actually do that async effect and then resolve it in a set state. Yeah. So those of you who are familiar with hooks and familiar with doing any sort of the equivalent of this would be a event handler or a component in mount or some sort of lifecycle in the class React class component world. React suspense is a more declarative way. This is very imperative, do this, then do this, then do this. React suspense is more declarative way of saying, here's a resource, and then go fetch it, and React will figure out the promise resolution for you. So the whole idea would be something like this. So I have here an API that basically fetches from a serverless function. I work at Netlify, so I set up this function by myself. And actually, I can just show you what it does, because last time I didn't do that, and people were kind of lost. This function only does one thing, which is you give it a number, and it gives you a number of images back, right? So I have here 1, 2, okay, 3, okay, 4. So basically a very, very simple API, right? You just toggling the query param, and it gives you a different response back. Okay, so over here, so that's a simple fetcher function, and then it does some post processing. Not really important. But what happens? What's important is over here. The way that React wants you to work with suspense is you wrap it in a resource, and this is kind of how it does. So you pass it a promise to resolve. And then it tracks whether it's resolved or it's been resolved with a success or resolved with an error, or it's still pending. If it's still pending, it's going to tell React so that it doesn't transition the whole thing yet. Okay, so and then we'll wrap it in this create resource API. That's just something that's standard if you go look at the docs for React suspense. Okay, so we're going to import that. I think we can get rid of this. So where is my dog app? Okay, I think this works. Oh, this doesn't work. Okay, so why? Because the main way that so you can see that it's actually very simple we're just creating a resource from our API. Remember, it's just wrapping that fetch function, right? And then we're just reading from it. We're not saying like go and fetch and then use effect and then set state or do something with component this one. You're just reading from it as declaratively as you read from hook state, right? And in your code, you can just use that as you get back an array and then you can do docs.map and then you map it onto an image just like you would do in normal code, as though you were reading from memory. But you're not reading from memory. You're actually doing an API fetch, and that's all abstracted behind inside of there. It's just a much simpler API, and it manages the transitions well for you as well. But we haven't implemented React suspense yet. That's why nothing's showing up. So the goal, the last part of this talk is about how to explain that. Okay, so inside of this promise, the way that we actually resolve this this promise is we actually throw the promise up. So we are past a suspender function, and that's the function is this fetch docs function. Well, it's this suspender function that wraps the promise over here. We're past it here, and we throw it upwards, and we expect React to catch it and then render it, and then resolve it for us. And once it's resolved, it re-renders itself to that sort of resolved state. So in order to do that, we need to actually build that functionality into React itself. So where are we going to do it? Over here, right? And for me, I think the best way that I figured out how to do it was to catch this perform unit of work. So perform unit of work is where everything inside of there is where you're doing your app code, right? So if I add a try catch around this, it should work. Which means that any error coming out of this, right? It's either a promise or it's not a promise, right? So if type of error, actually I'm going to use instance of promise. So if the error is made from a promise, then resolve it. If not, okay, I just locked myself into an infinite loop. It's choking a little bit. Okay, stop. How do I kill this? It's not saved. Don't worry. This is the fun of live coding. I mean, honestly, we're covering less content as we live code, but yes, that's probably what a smarter person than me would do. Right. Okay, here. So we don't need syntax highlighting, it's fine. But we'll just say like if it's a promise, we'll say like error dot then we'll actually resolve it by doing some other work. I don't think we actually need to do anything else apart from that. But and then if it's not a promise, we'll just actually rethrow the error, right? You just like keep throwing it up. Right? Just say it's not your taiti. Okay, so over here, I think we are done. Did I screw something up? Oh, yay! Okay, yay! So we're fetching dogs from the API. Except that I'm not setting state properly. So over here, once the promise has resolved, we actually need to tell React to reschedule again, and we already know how to do that, right? We actually can. We did the same thing in the useState hook by just setting the work in progress root and the next unit of work. So I think I can just do that by saying next unit. This is not like the by the book proper way to do it, but you're just scheduling another round of rendering again. So once this resolving is done, I think please show up. So work in progress root is also cleared. So I'm also going to do this. There, where is it? because work in progress root will be run into its null. Look, can I kill this somehow? Pretend it's not there. Okay. I think I did. Okay. So I do have a backup. Don't worry. This is for precisely this reason. Suspense work loop. Okay. Let's actually look at what my code was supposed to do. Okay. Oh, right. Okay. So sorry about that. Okay. So I was when you actually have an error that you throw, right, you're supposed to suspend the work. So I actually introduced a variable over here to keep that suspended work. So I'll just say, like, while I'm resolving this, like, choke first, and then and then go and resolve it. Once it's resolved, then you dot then on the promise, right? And then you schedule that new round of work to be done, and you set the suspended work back to the next unit of work again. So it continues rendering where it left off. Right, it's the whole pause and resume process again, which is a very fundamental part of Fiber. And now I'm screwed. Okay, all right. So, but you get the idea that we were able to modify. Like, once you have a good mental model, you know exactly where to go to implement new features, to understand new features. Even though this is nothing like the real code, right? But you understand the real features so that when you actually write apps like this, you understand fully what's going on under the hood, and you're a better user of React for that. Okay, so I'm just going to leave off with what else we covered and what we did not cover. So we covered today Fiber, linked list traversal, render versus commit, use state hook, the work loop, time slicing, and with a lot of difficulty, some suspense. But you get the idea that this is all doable by mortal human beings like you and me. But there's also other stuff. There's always this question of, like, okay, if you can write all that by yourself, why use React? And it's all this stuff, right? So the stuff that if you wanted to, you can keep cloning, but you probably just end up with the React code base itself. So feel free to be my guest. One of the new hooks with suspense that sort of tap into the suspense state. And the scheduler underlying this whole thing, because React doesn't actually use React request idle callback. It uses a scheduler library that is meant to be shared with other libraries. And so these are ways to tap into the scheduler function alongside with the regular hooks that you should already know. So yeah, this is all that. This is what's missing in React. This is what's in React that is missing from this talk. But hopefully you get a better understanding of the mental model. And thanks very much.
Questions? Okay. The way RK takes questions is we pass around a floppy.
Where's the lab?
Press class 2.
Class 2.
Can you please go back to the code where we have the suspense, suspended work. So I'm just wondering what happens if, let's say, suspended work got expired because something else happened during the time period, and then you resume the work. Will there be any conflict or?
Yeah. So the official answer is that there is actually a queue of effects, and React will always think of it exactly like Git. When there's like a Git commit and one after the other, React will always apply them in order. So while there's suspense going on and there's work to be done, it will not commit to the DOM. It will just hold that state update that you scheduled in memory, or let's say it's a higher priority. It'll actually render that first, and then it'll resolve that promise and then re-render with the work that we did over there. So it's always in sequence, and it will show on. So React has an idea of what the queue is, and React will, but what shows on screen is based on priority. So there's a concept of a priority queue. Like there's 5 different levels of priority in React. So if there's something that's high priority, that will flush the screen first. But when you apply something low priority and that gets resolved, that will be your whole app will be rerun again, the whole thing, and then the final output will be flushed to the screen as well. So whatever conflicts, like the whole model of React is meant to be declarative. Like everything is declarative here, right? And that's why it's so much easier to think about, because when in doubt, just rerun again. So once you have that two conflicting, I mean, it's not conflicting. It's just different states that are being set, right? And you don't know how they resolve it towards the end. So just rerun the whole render again. Which is why, one of the reasons for moving to hooks and away from the class-based lifecycle model is because they don't want to promise you that we'll only run component did mount once. They don't want you to do that. They may stop rerun or just re-render again because something else up the tree updated multiple times, and you may not be in control inside of the component. So they don't want you to tie it to the component instance that much.
Just to make sure I understand it correctly. So
yeah.
You're saying that, let's say we click to get a dog picture and it's fetching, and the user decided to switch to another tab maybe, and showing it's higher. Let's assume it's higher priority.
The switching of the tab.
Yes.
Yep.
The switching of the tab, and
yep.
then you show that React will commit the work and to the screen that displaying another tab. And after displaying that tab, the dog picture arrives. So
just it won't show on screen.
React will actually re-render the whole thing to make sure that everything is correct.
Yes. So if you think about what happened in sequence, is you send the fetch, right, and then you send the switching of the tab. But over on the rendering side, the switching of the tab will always take priority because that's a high level visual element. So the dog fish, the dog promise, because promise are not cancelable normally, that will still resolve, but it just won't show up.
It won't show up.
Right? Because you already, the more important thing is that every single time I'm re-rendering the app from scratch, and over here there's a router that says okay, tab 2 now. And I only show tab 2, so the tab 1 with the image doesn't show.
It is not shown, but
the promise will still resolve.
Since I already registered the resolving, but still it will trigger a React to at least do something. Or
no. Yeah, it will just be ignored.
Okay.
Yeah.
Thanks.
Good question.
Actually, it's like, for your example, with the data fetching, you need to implement the data cache, right?
Yeah, so we have a very simple cache over here. Where? So the cache is just this arc. So this is a last, whatever was last called is the cache thing. So it's like a, what do you call it? Memorize one effect. So I just store it inside of current arg. If current arg is if the current arg is different, then I'm just invalidating that cache and going to fetch the other one. But obviously you can have a deeper cache than that. In fact, I think there's an interesting case to be made to put this cache inside of service workers. Yeah, because then your app just loads instantly, right, with all the cache that you've done before.
My question is that actually this one should work in current React version right now. The only one missing is that good implementation of the cache, right?
Yes.
Yeah.
So
if you try something like this in any production application, because I don't dare to.
Yeah, well, so right now the status is that it's still experimental. So if you go react.js.org/concurrent, it's still experimental. So they have not pushed it in, they have not sort of marked it as production ready for most people. But they have been using it in production at Facebook for a year. So it's up to you what you want to do.
I remember that 1.5 years ago when I first listened to the talk from Jan in the React Island or something, right?
Yeah.
They introduced that and they promised that, okay, this one will be the future, and actually it's 1 month and 1 year and 8 months already since that day.
Yeah.
But I gave up ideas already.
So the main thing, the interesting thing is that, I mean, who among us has not estimated and then been way off? Like, so I don't knock them for that at all. The main thing that they're, like, what I presented to you is entirely client-side. And the main thing they're focused on is actually the server-side story. How do you server fetch and then and stream it down to the user and hydrate in an intelligent fashion that doesn't screw up your state. So that's, they've been working on that, in fact, probably more than the rest of these details. Like, they could probably bang this out if they want to, but it doesn't matter if the server-side rendering story is not fleshed out for them. I'll even show this to you. Like, this you cannot do. Like, so Dan just tweeted this out recently. So this is hydration. So hopefully people know about server-side rendering. Like, you render on a server, you send HTML, and then you send the JS, and then you hydrate into a full SPA. Yeah. Okay. So over here, this is the idea for suspense-enabled hydration, right? Where there's no JS loaded, so whatever buttons you have, HTML you have is not interactive, and then you manually load the JS, and that just immediately gets hydrated with the sequence of events that you already did. So, and you can chunk your JS up, so you can load these separately. So if the user never uses your nav or your sidebar or something, it never loads with JS, and you only load the stuff that is being used. So that's okay. So this is fine, right? This is like, okay, impressive, whatever. You can do that in normal JS, but you cannot do this unless you have a complex enough runtime. So that question just now about applying that sequence of events and having that queue in mind lets you be able to do this. So we're clicking multiple things and click, 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 click. So these states might have interaction effects, right? And you don't really know, like, so we'll just refuse to show until you load both JSs, and then the clicks will be registered on both. So it's like, if the required dependencies all down the chain are not resolved yet, we'll just never show it. But if they're all resolved, then we'll show all at once, and it will be consistent state throughout. That makes sense. So like the whole idea is that you as an app author, you only declare the intentional screens that you want to show, and all the unintentional loading states in between will be managed by React, not by your. I mean, previously it was managed by your code. You will be like, you use like, I don't know, React Async or component inbound, or React Loadable is another very popular library. But this is all now being absorbed into the framework. I guess one more question. Anyone? I'll put this on the GitHub thing, but hopefully it doesn't scare people off too much. That, like, yeah, I messed up the coding, but I'm speaking as I code, so a little bit messy. But the amount that we just looked at was 133 lines of code today. Nothing. But hopefully it gives you, like, this is the best place to start studying for a better mental model of React. Okay, cool. Thank you.